So this is going to be a video on finding intervals of increasing and decreasing. And the problem we're going to be looking at, it says consider the function y equals 3x to the 2/3 power minus 2x. And then it's asking for the critical points where the y value is increasing or decreasing, and you have to find all the coordinates of the extrema. First thing I'm going to do is write down the function that we're looking at. So it's going to be, the first thing the problem wants you to do is find the critical points. So what I'm going to do is first I'm going to find the derivative of this, so that it wants you to find the critical points. So first thing I'm going to do is find my y prime. So using the power rule, I'm going to bring the 2/3 down. You should get 2x to the negative 1/3 minus 2. Now, because we're going to be doing calculations with this, I'm actually going to rewrite this in the standard form that we're kind of used to in mathematics. So it's going to be 2 over x to the 1/3 minus 2. Okay, now the first step, it says find the critical point. So to do this, I'm going to need to set this derivative equal to 0 or does not exist, because if you remember, that's our definition of critical points. You take the derivative, you set it equal to 0 or does not exist, and you solve for x. So that's what we're going to do here. It's easier to solve for does not exist in this case first, because you just can't divide by 0. The only time we're dividing by a variable here is right here. There's 2 divided by x to the 1/3. So it does not exist. X cannot equal 0, because then you'd be dividing by 0, and that is not possible. Setting it equal to 0, what I'm going to do is add 2 to the other side. So you're going to have 2 over x to the 1/3 is equal to 2, because I just added 2 to the other side. 2 plus 0, it canceled out on this side, and then 0 plus 2 is 2, so you end up getting this. Okay, I'm going to divide both sides by 2, so this becomes 1, this becomes 1. Then I'm going to multiply both sides by x to the 1/3 power, so you're going to get 1 is equal to x to the 1/3. From here, I need to get rid of this to this 1/3 power, so what I'm going to do is just raise it to the 3rd power. If you remember, that cancels exponents. Algebra 1 right there, that cancels exponents. X is equal to 1 to the 3rd, so x is equal to 1. So we have one critical point here and another critical point here. So that's A. Next, it says indicate the intervals in which y is increasing or decreasing. Now to do this, you're going to want to make a critical number line. So I'm going to make a number line and put my critical numbers on it. Okay, so I have 0 and 1. You want to test each interval that's in between these critical points. We know the derivative at the critical point 0 does not exist. We know that the derivative at 1 is equal to 0. So we already solved those. We need to test every other point and to see whether it's positive or negative. If the derivative is positive, then it's increasing. If the derivative is negative, then it's decreasing. Okay, so we're going to test some humongously negative number over here. So if you do that, you're going to end up with 2 divided by some negative number, some huge negative number. So it's going to be a really tiny number, minus 2. So you're going to end up with a negative value here. So I'm going to put a little negative here for my f prime. So my f prime is negative in that interval. That means it's decreasing in this interval. Okay. Next, I'm going to put some value like 0.5 or some other number that's in between 0 and 1 here. And if you do that, you end up with 2 divided by some positive fraction that's actually small. So it's actually going to be a bigger number. So it'll be like 2 divided by some small number ends up being a big number. And this number is going to be bigger than 2. So it's going to be bigger than 2 minus 2. This means it's going to be positive. Now, if you want, you can actually test exact values if you don't want to just think about it using number sense. You can just plug it right into your calculator and see what it ends up being. In this case, it's positive. So this is going to be increasing. Okay, and then let's just put positive infinity in here. So 2 divided by infinity, this ends up being 0, and you have 0 minus 2, so that would be a negative. So this would be decreasing. Okay, so this kind of answers our question, what are the intervals in which it's increasing and decreasing? So the function is decreasing from negative infinity to 0, increasing from 0 to 1, and then also decreasing again from 1 to infinity. So I'm going to write that in interval notation. So it's increasing from 0 to 1, so 0, comma 1. Okay, also make sure it's always open interval. You can't include the points, the end points on that, because it's not technically increasing at 0 and 1. It's increasing between those. Okay, it is decreasing from negative infinity to 0. So I'm going to put that in. You always got to put the smallest number first for interval notation. So negative infinity to 0, then from 1 to infinity. So I'll do a union 1 to infinity. Okay, that's part B, finding the intervals where it's increasing, decreasing. Now we're going to do part C, find the coordinates of the relative extrema. Well, this increasing, decreasing tells us where the relative extrema are. So if it's going from decreasing to increasing here, that means it's going down and then up for this interval. If it's going down then up, that means that 0 where x is equal to 0 is going to be a relative min. We just need to figure out the y coordinate for this. So to figure out the y coordinate, we're going to use the y equation right up here. So you plug in 0, you end up with 0 minus 0. So it's 0, 0. It's a relative min. Okay, so this is one of the critical numbers that shows us a relative extrema. The other one would be 1 here, and the function is increasing then decreasing. So that would make 1 be a relative max. Now, at 1, you also need the y value here. This equation up here gives you the y. So if you plug in 1, you get 3 times 1, which is 3, minus 2 times 1, which is 2. So 3 minus 2 is 1. So at 1, 1, you're going to have a relative max. Now you're going to want to check both of these on the graph. If you're allowed to use your graphing calculator on this, you're going to want to check both of these points to make sure that it's a hill and a valley at these points, and then it's increasing and decreasing at those intervals. So if you have any questions about anything in this video, let me know.